Good morning, good morning, good morning. Hope all is well and everything is all right. Got about
Good
four,
morning.
four or five people still connecting. Did somebody just unmute? Did anybody say anything?
Yeah, I was just saying good morning.
Oh, thank you. Good morning. Good morning.
Good morning, Professor.
All right. Hey, hey. All right. So, look like everybody is good to go. All right. So, oh, we still got people just jumping in. That's all right. So, we're gonna go ahead and get into 1.6 today, I believe. Um, what's the last day the driver's class still receive the money back? I have to look that up. As far as drop. So if you stay on after class, I can see if I can find it for you before you leave. So don't let me forget. Okay, so I believe we left off at 1.6. This is 161. Yep. Any general questions? Yeah, no problem at all. Not a problem at all. Any general questions before we get rolling? Everybody good? Everybody straight? All right. Let's go ahead and do it. All right, so 1.6 is entitled Other Types of Equations. Looking at one other thing before we get in there. All right, cool. All right, so other types of equations. So our first equation today is going to be 3x to the fourth equal to 27x squared. So our highest exponent or the degree of our equation is 4. So we're looking to get 4 solutions. First thing we'll do is set one side equal to 0. We can do that by subtracting 27x squared from both sides. And that puts us in this position, 3x to the fourth minus 27x squared equal to 0. And then like we did last class, we can factor. And erase some of this. So our first factorization would be 3x squared times x squared minus 9. We just pull 3x squared from each term. All right. Then after that, right here, we have a difference of squares. That's x squared minus 9. In other words, x squared minus 3 squared. And when we have that situation, we can break it up into x plus 3x minus 3. That's one of the formulas that we have in factoring. Look at that as being x squared minus 3 squared. So whenever you have that type of scenario, you can break it up into x plus 3x minus 3. All right, any questions so far? All right, and just like we did last section, once we factor completely, we can set both parts or each part equal to 0. And that's what we're doing right here, 3x squared equal to 0. X plus 3 equal to 0. Then x minus 3 equal to 0. And then solving for x. All right. And so remember, we're supposed to get 4 solutions. Don't forget, whenever you take the square root of both sides, that would be a plus or minus. So in this case, we end up getting a repeated solution of 0. So you don't have to write it 2 times, but right here is where you would have had 2 solutions if that was something other than 0. But in this case, since it is 0, there's no such thing as a plus 0, a positive 0 or a negative 0. So the 0 is just one solution. But that's where all 4 solutions would be in this case. You have 0 twice, then -3 and +3. All right, any questions on that?
I don't really understand how, like, scroll up a tad bit where you put all that up there. The x squared equal minus y squared equals x plus y.
Oh, that's the difference of squares formula. So that goes back to factoring.
Okay.
So yeah, so it just says that if I have that type of scenario, x squared, in this case it was 3 squared because 9 is 3 squared, then it's saying that I can break it up into x plus 3, x minus 3. So it's
Okay,
like,
thank you.
yep,
Yeah, I see.
yeah, okay, you good, okay, yeah. So that's all that was leaning on, your difference of squares formula. All right. Anybody else before we go to the next one? All right. So next one, x cubed plus x squared equal to 4x plus 4. Once again, we want to set one side equal to 0. So if we subtract 4x and subtract 4 from both sides, that will give us x cubed plus x squared minus 4x minus 4 equal to 0. All right. Next step, we want to factor just like before. Once it's set equal to 0, we look to see if we can factor. This time we're going to use the factoring by grouping technique. Whenever you have 4 more terms, you're going to factor by grouping, in which you group together the first 2 values or first 2 terms and the second 2 terms. And that's what I did right here. All I did was group them together, put x cubed and x squared in a set of parentheses. Also, I included in the second set of parentheses -4x and -4. So be careful. Make sure that this minus sign is included with the 4x. A lot of times people make a mistake and put the minus sign on the outside. But if you do that, then you change the value of the equation. That minus sign needs to stay attached to the 4x inside of your parentheses. All right. From there, you factor out your GCF out of each parentheses. So in this one, I was able to pull out x squared from each term. In this one, I was able to factor out -4 from each term. Now, in order for us to move further in this process, these have to be exactly the same. Whatever's left in the parentheses have to be exactly the same in order for us to go further. If not, then you have to either go back to the original problem, rearrange terms, or it can't be factored by using by the grouping technique. But you see that we have x plus 1 in each set of parentheses, so that means that's what they have in common. So we're actually factoring out x plus 1, bring that to the front right here. And then what's left is x squared minus 4, and that's what's right here. All right. Questions so far? Once again, all of this is all of this is your factoring techniques. So make sure you're okay with your factoring. Then once again, Difference of squares. Same thing that happened with the x squared. X squared minus 9. Here we have x squared minus 4. This is x squared minus 2 squared. So that's why we could break it up into x plus 2x minus 2. Same thing we did with x minus 9. That was x squared minus 3 squared. So we broke it up into x plus 3, x minus 3. All right. Problems. So now you set each piece, once it's factored completely, you set each piece equal to 0, and then solve for x. Subtracting 1 from both sides, subtracting 2 from both sides, then adding 2 to both sides. All right, any questions on that one before we look at the next one? All right. Okay, let's go to the next one here. So next in this section is solving radical equations. So it says, if necessary, isolate one radical to one side of the equation. Step 2, raise both sides of the equation to the power of the index of the radical. So we're gonna put numbers on this and, make sure it makes sense. But just looking at the steps first. I'll give you a chance to write down 1 or 2 before we go to the next one. All right. Third step, we're gonna solve the equation. If a radical still exists, then you have to repeat steps 1 and 2. So it is possible to have more than one radical in your equation. Then step 4 is check your solutions. Notice I said that is a must. Reason being is because once you square both sides or raise both sides to an even power, it is possible that what you did may have created an extraneous solution. So you have to go back and check your solutions. All right, can I scroll up? Everybody good to look at this first one? All right. So first one we're looking at the square root of 2x minus 1 plus 2 equal to x. So first thing we want to do is isolate the radical. That's the first step. If necessary, if your radical is not on one side of the equation by itself, you want to make that the case. So we want to isolate the radical, so we'll subtract 2 from both sides. So now we have the square root of 2x minus 1 equal to x minus 2. So that's the end of the first step. You want to isolate your radical. If it's not already on one side of the equation by itself, you want to make that the case. Next, you want to raise both sides to the power of the index of the radical. So if there's nothing there, they assume you know that's 2 as the index of the radical. Other than that, you will see the number, whether it's 3, that's the cube root. Here would be fourth root. You would see the number. Once again, if you don't see the number there, they assume you know that there's a 2 there. So we're going to raise both sides to the power of 2. We're going to square both sides, in other words. And the square and the square root over here will cancel. And on this side, we have x minus 2 squared. So raising both sides to the index, to the power of the index of the radical, will cancel out that radical. Any problems? All right, so we can go ahead and solve. Remember, for step 3, you would go about solving. If it still had a radical included, then we would go back to step 1. We don't have that in this case, so we will go ahead and go about solving. So let me erase some of this to make sure we are all good. All right, so first thing we want to do is go ahead and FOIL out this x squared, x minus 2 squared, excuse me. And that's what I have right here. Just to FOILing out this, distribute your x, distribute your negative 2 within the to each parentheses, and to the other parentheses. And so that'll be x squared minus 2x plus 4. And then the minus 2x and minus 2x in the middle will combine as like terms to be minus 4x. All right, any problems with that? And then we want to set one side equal to 0. So I subtracted 2x and added 1 to both sides. And that gives us x squared minus 6x plus 5 equal to 0. All right, questions? Any questions? All right, so now what I would do is go ahead and factor. Remember, if you don't want to factor, you can use your quadratic formula. Remember, that's an option as well. Most people don't want to go all the way to completing the square, but you can use your quadratic formula. You'll still get the same answers. So factoring that, I get x minus 5 times x minus 1. Set each part equal to 0. That's x equal to 5, x equal to 1. Those are my two solutions. All right, hey, everybody good before we look at step 4? All right, so we got to check these. So if you were to plug them back into your original equation, you go back to your original. Excuse me. So the first one, x equal to 5. Plug it into the original equation where you saw where you saw x. So we have 2 spots in the original equation where x was. So 5 should be there now. And that's what we did right here. So 2 times 5 minus 1 under the radical would be 10 minus 1, which is 9. And then square root of 9 is 3. 3 plus 2 is 5. So that one checks out. Then looking at 1, x equal to 1. Once again, we plug 1 into both spots where we see x, and then simplify and see if we end up getting a correct or true statement. So here, 2 times 1 minus 1, that's 2 minus 1, which is the square root of 1. Square root of 1 is 1. That gives us 3 on the left, but I still have 1 on the right. So that one does not work. So my solution is just the x equal to 5. Once again, x equal to 1 did not work. So when you go about solving your radical equations, you do need to go back and check.
Remind me, x equal 1 doesn't work because it has to be a number greater than 2, correct?
No. In this case, it all comes down to this final statement right here. So when you go plug it in, notice I have 5 equal to 5.
Yeah, and then 3 equal to 1x,
Right.
or to 1, yeah.
Right. So that
Okay,
just lets us know right here.
gotcha.
And you just said something real key. So maybe I'll put a circle around it like that. Yeah. All right. Anything else? Anybody else? Make sure we're good with our understanding.
This is like a small question,
Mhm.
but where is it? Can you scroll up a bit? Where is it? It was like because we did like the same thing,
Mhm.
but why didn't we do like trying to find where it was. Why didn't we do it was shit, where was it? It's like we dropped down the same thing, but we ain't put it square.
Um, are you talking about right here or when we squared both sides?
Hold up, wait, let me go find it before.
Okay.
Never mind, I lost it. I'm sorry.
Okay. Well, if you think about it or you find it, feel free to, hit me with that question. Make sure you're good.
Yeah, my bad. I've been up since 4.
I did have one quick question.
No problem.
Is this some, like, would you want to check every problem, or is there some, like, telltale, like, some sign that would make you think, oh, wait, one of these isn't going to work?
Most of the time, this occurs when you're raising both sides. Let me get there. If I can. Okay, there we go. When we raise both sides to an even power, normally that's when you will have one of them not working for you. Yep. So here we raise both sides to the second power. If we were raising both sides to the fourth power, I don't think you guys will get one like that, but I'm just saying, as you go throughout your mathematical careers, raising it to an even power normally is what triggers this situation.
And not odd powers, just even?
Right, not odd necessarily because it goes back to the idea of when I take the square root of 25, um, it's 5 because 5 times 5 is 25, but also negative 5. If I can write, negative 5 times negative 5 is also 25. So it goes back to that even relationship, the even power relationship.
Got it. Okay, thank you.
Mm-hmm. Yeah. All right. All right, so let's try one that has more than one radical involved. So here we have the square root of 3x plus 1 minus the square root of x plus 4 equal to 1. So we want to isolate one of the radicals. Doesn't matter which one you decide to move. Here, since this one is negative, or is there a minus sign in front of it, most of the time what you would do is go ahead and subtract that one. And, I mean, not subtract that one, but add that one to get rid of the subtraction. So that's what I did here. Add the square root of x plus 4 to both sides of the equation. And the result is what's in the box. So we have the square root of 3x plus 1 equal to the square root of x plus 4 plus 1. Everybody good on the first step? All right, second step. Once again, the index of our radical is 2, square root. So we're going to square both sides. Square root and square cancels out on the left. And then on the right, we have the square root of x plus 4 plus 1 squared. Any problems? So just like before, we're going to FOIL this out. So let me erase some of this stuff. Yeah, I guess I can erase it too. All right, so first thing we're going to do is FOIL. So that's going to be the square root of x plus 4 times the square root of x plus 4, square root of x plus 4 times 1, then 1 times the square root of x plus 4, and then 1 times 1. Before we look at simplifying the expression, questions on foiling that out, how we got here. All right. So this square and this square root is going to cancel. I can actually combine these like terms. You know, when you don't see anything in front, assume you know there's a 1 in front. And then that 1 is just in the back. There's nothing I can do with that as of yet. So this simplifies to just x plus 4. All we did was get rid of the radical. Then adding these two together would be 2x plus 2 square root of x plus 4. We're just adding the numbers in front of it. Like I said, that's just 1. So 1 plus 1 gives us that 2. And like I said, this 1 is still here in the back. Any problems with getting here?
So when you're foiling out a square root, do you include everything in the square root as one number?
Yep, you treat a quantity as 1. Yep, so that's why we just did x plus 4 under the radical. You know, we did x plus 4 times x plus 4, which gives us x plus 4 squared.
Gotcha.
Yep.
Thank you.
Yep, not a problem. And just anybody else, just to reemphasize what we're saying there, same thing as if I had x square root of x, well, square root of 3 times the square root of 5. All you're doing is multiplying what's under the radical. That gives us the square root of 15. So that's what we were alluding to right there. What was under the radical is x plus 4 and x plus 4. We multiplied those two quantities together, left them intact, and just wrote x plus 4 squared, so that that square and square root can cancel for us and reduce down to just x plus 4. All right. So now we can combine the like terms, 4 and 1 will give us just this 5 right here. And this is our most simplified expression up to this point. So don't forget we did have x plus 3 on this left side of the equal sign. 3x plus 1, excuse me, I said x plus 3, but 3x plus 1 on the left side of the equal sign, that's still there. All that we did over here is just simplifying the right side of that equal sign. All right. So notice that we're not done with step 3 yet, because if there's still a radical involved, then we need to isolate the radical again. That's what we're talking about right here. We need to isolate the radical again. So that takes us back to step 1 because we still have this radical involved. So I'm going to subtract x and subtract 5 from both sides of the equation because these are over here. I need to get this radical by itself. And that gives us this expression or this equation. Subtracting x from both sides gives me 2x. It cancels out on the right. Subtracting 5 from both sides gives me -4 on the left. It cancels out on the right. And now this is on one side by itself. Make sure we are okay. All right, next move. Raise each side to the power of the index of the radical. And so we're not looking at this stuff yet. I'll put it back up in a second. But all we did was square both sides of the equation. Oh, give that back.
I'm having a little trouble remembering how do we know what power to raise it to again?
It will say it right here in your radical. So let's
Okay.
say if I have the square root of x, when you don't see anything there, they assume you know there's a 2. If it's a cube root of x, then you're going to raise both sides to the third power. Fourth root of x, raise both sides.
That's right. Okay, I remember now. Thank you.
Yep, not a problem. Let me go ahead and erase this stuff, get back to where we were. All right, so let's go back. All right, there we go. So that's where we are now. We raise both sides to the power of 2. Now, also let me point out that this is a 2, like 2 times. That's not the index of your radical. That 2 is sitting in front of your radical. That's not the index of your radical. Once again, there will never be a 2 on the inside of that. They assume you know when you don't see anything, there's a 2 there. So that's 2 times the square root of x plus 4.
Yeah, that's the main reason I asked was because I couldn't remember, and I knew that was 2 times the square root of x plus 4. Not that
Right.
wasn't how we got it.
Yeah. Yeah, you on it, sir. Yeah, most definitely. You got it. So, yeah, I know this is one of those problems where they put stuff in there. You're like, this should have used a different one to, be the first time we explained it. But,
Try to
that's what
trip
it
you
gives
up.
us. Say it again.
I said something kind of just try to trip you up, or
Yeah. Well, I don't think they did it on purpose. Sometimes numbers just work that way, so. All right. So if we're going to go ahead and square both sides now, when I square this on this right side, it's going to cancel out the radical, but it's also going to affect the 2 that's sitting on the outside. Remember, that's 2 times. So it's going to be 2 squared. And then, so that will give us, 4 times x plus 4. Once again, the radical is removed. So all you're left with is x plus 4. Then 2 squared is 4. So that's why we have this right here. And then on this left side, that's just your binomial distribution wherein you will FOIL it out, 2x minus 4 times 2x minus 4. So that would be the result of both sides of your equation once you simplify and distribute as much as possible. Distributing the 4 on the right gives you 4x plus 6. Then on the left, doing your distribution, that's 4x squared minus 16x plus 16 once you finished up. All right, any questions? So let me erase this real quick, make sure we are all on the same page. So now we have 4x squared minus 16x plus 16 equal to 4x plus 16. And you see here in the red, you want to set one side equal to 0 so we can move forward in our solving process. So that means everything over here I want to send to the left side. So I will subtract 4x and subtract 16 from both sides of the equation. My result will be 4x squared minus 20x equal to 0. We can factor now. Once you set one side equal to 0, you factor. And then we can set each piece equal to 0 and solve. So 4x equal to 0, divide both sides by 4. That is 0 as a solution. And then add 5 to both sides. 5 would be a solution. All right, any questions before we look at our check? We'll check our solutions. All right. So once again, we're going to go ahead and throw both of those into our original equations. So throwing in 0. So there were two spots where x is located in the original equation. So we plug in 0 accordingly. Simplify the square root of 1 minus square root of 4. Then that'd be 1 minus 2, which gives us negative 1 on the left side. And that's not equal to 1. So it does not work. Then on the right side, plugging in 5, end up getting 15 plus 1 under the first radical, 5 plus 4, which is 9 under the second radical. So the square root of 16 minus square root of 9, 4 minus 3 is 1. And that checks out for us. What equal to 1? So x equal to 5 is our only solution. All right. Questions? Any questions before we look at the next one? Can I scroll up? Anybody still copying? All right. All right. So we're looking at a radical equation of the form of x to the m over n power. So if m is even, top number on your exponent, the fraction of your exponent, if that is even, when you go about solving, we're going to raise both sides. In both cases, whether m is even or odd, notice we raise both sides to the power of the reciprocal of the fraction. We're going to flip the fraction, raise both sides to that reciprocal in order to be able to cancel out what's being done to x. But if m is even, then that's going to be plus or minus. We're going to have to use the square root property, and that's going to yield two solutions. All right. Now, if m is odd, we're going to follow the same process, same procedure, but you only get one solution. So when we put a numbers on it, you'll see why that occurs. But if m is even, it causes us to use the square root property, which means I have to use plus or minus. But if m is odd, we do not have to do that, and only one solution will be produced. All right. Are we good? All right. So just to make sure we're okay with what it means to have a fraction as an exponent, looking at 8 to the 2/3 power, the top number is always going to be the power. Bottom number is going to be your root. Somebody said something in the chat. All right, hold on one second, guys. There's somebody that wants something in the chat. Hopefully, if that's high enough, let me know. If not, I'll scroll up some more. Your top number is your power, bottom number is always your root. Doesn't matter which order you apply them, as long as you keep or hold true to the top number being your power, bottom number being your root, then you will be okay. So notice we have 8 to the 2/3 power. That's we just in the first one I decided to do the cube root of 8 and then raise it to the second power. Cube root of 8 of 2 is 2, then 2 squared is 4. In the second one, I decided to raise it to the second power first, then apply the cube root. So 8 squared is 64, then take the cube root of that is going to be 4. So notice regardless, I'm going to get 4. If you were doing it by hand, it may matter because you're dealing with familiar numbers versus unfamiliar numbers. If you were to square something first or raise something to a power, then try to take the root of it, may not be as simple. But if you just were to throw it in the calculator, it doesn't matter. Either way, you'll get the same result. But the thing you have to hold true to is that your top number is your power, bottom number is your root. Notice right here, it didn't matter what order I did them in, but we still did the cube root and we still did the second power. So that's going to hold true regardless. All right, so before we do an actual equation with this type of scenario, any questions?
Could you give us like a few seconds to copy this down, please?
Yep, not a problem.
Thank you.
Quick question. When we have x equals plus or minus k to n over m, how many solutions is that?
That's only going to be 2.
2. Okay.
The positive representation of it and then the negative representation of it.
Okay. Thank you.
Yep, not a problem. All right, you guys let me know when I can go to the next piece. All right, anybody else before I scroll up? All right, so let's look at a problem with this going on. So here we have 3x to the 3/4 power minus 81 equal to 0. So now if we're going to use the principle that we just finished talking about, let me scroll up a little bit. Notice that whatever was being applied to by the exponent that's a fraction is on one side by itself. All right. So if we're going to do that here, then I need to get x to the 3/4 on one side by itself. I need to isolate x to the 3/4. So I add 81 to both sides. And that gives us this result. You add 81s to both sides. 3x to the 3/4 equal to 81. And then we will divide both sides by 3. And that will give us this result. So before we go any further, is everybody okay getting right here? We added 81 to both sides, and then we divided both sides by 3. All right, so next step, if you go back to what they did next, was they raised both sides to the reciprocal of that fraction. Notice they had m over n at first. They raised both sides to n over m. So that's what we're going to do here. We have 3/4. So we're going to raise both sides to 4/3. And what that does for us is that on this left side, whenever you're raising a power to a power, your exponent rules. Whenever you raise a power to a power, you're going to multiply your exponents. And that's what we're doing right here. 3/4 times 4/3 will reduce down to 1. And that cancels out that the fact that you had a fraction as an exponent. Now
Is
on the
this
right,
for everything?
when you say this for everything, what you mean by that?
Like all the fractions?
Well, it cancels out the fractions on this left side. We still have one on the right side to deal with, though.
Uh-huh, I got you.
Yeah.
But everything on like the whatever we like flip around will always equal 1 though, right?
Yes, yep.
Oh,
So I see what you're saying. If I had 2/5 times 5/2, yep, that'd be 10 over 10, which would reduce down to 1. Yep. So that will always work for us. All right. So now that we have just x on the left, on the right, we need to simplify 27 to the 4/3 power. Once again, if you throw 27 to the 4/3 power in your calculator, it doesn't matter. It'll just do it for you. But if I was doing this by hand, remember the bottom number is your root. The top number is your power. What I do not want to do is do it the other way. In other words, do 27 to the 4th power and then try to cube that, because I don't know 27 to the 4th power off my head. So what I would do is go ahead and apply the cube root first and then raise it to the 4th power. And that's what I did here. Like I said, the positioning only matters if you're doing it by hand, like I'm doing right now. So the cube root of 27 is 3. And then 3 to the 4th power is 81. And that is my answer. So notice, let me go back here. Our top number was odd, and so we only had, excuse me, we only had one solution. So, because we had that, our top number was odd, that means we got one solution. So any questions before we do this again? But this time we'll have our numerator to be even. All right, try to scroll up. Anybody still copying? All right, let me erase this stuff. All right, so here we have x to the 2/3 power minus 3/4 equal to negative 1/2. This is the equation right here. All right. So first thing we want to do, just like before, is to isolate what's being applied to by the fraction that is an exponent. So we have x to the 2/3. We want to get that on one side by itself. So I'm going to add 3/4 to both sides of my equation. Over here, don't forget your fraction work. In order to be able to add or subtract fractions, you have to have a common denominator. And so that's all I did over here in the purple, is just go ahead and went through the common denominator process, fraction process. Common denominator is 4, so I multiply top and bottom by 2 of that first fraction, gives us negative 2/4. Negative 2/4 plus 3/4 is 1/4. So that's why we have right here x to the 2/3 equal to 1/4. All right, any questions? All right. So now, same process as last time. Once we get to the point where we've isolated our quantity that's being applied to by that negative exponent, I mean not negative exponent, fractional exponent, we go ahead and raise both sides to the reciprocal. So our fraction was 2/3, so now we're raising both sides to the power of 3/2. All right. So why is this key here? Now my root is a 2. Remember we talked about our numerator being even, which was 2. When we flip our fraction, that means now the denominator is 2, which is going to be a root. So essentially, we took the square root of both sides. And that's why you have to do plus or minus. Whenever your numerator initially is an even number, eventually it's going to be a bottom number, which means it's going to be the root. And that means you actually taking the square root or fourth root or whatever, even root of both sides. And that's why you have to do plus or minus. All right. So that means right here I have the square root of 1/4 raised to the 3rd power, but also, like I mentioned before, plus or minus has to be involved. Square root of 1/4 is 1/2. Then 1/2 cubed is 1/8. So that is plus or minus 1/8 as an answer. Over here, just somebody had asked me about the powers, and I was just showing them that, even power, when you 1 times 1 is 1, -1 times -1 is +1. But then when you look at a odd, you're going to get a distinct answer. -1 times -1 times -1 is -1. +1 times +1 times +1 is +1. So that's why it doesn't happen when you have an odd powers, because you will always have a distinct answer. But when it comes to an even power, going back here now looking at the 4th power, I'm still getting +1 because our negatives will cancel out. So somebody asked me a question about that. So that's where that was from. You don't have to necessarily copy that. But our answer is right here, plus or minus 1/8. All right. Questions? Any questions? All right. Everybody good with that before we? All right. So this next one, we're talking about equations in quadratic form. So we have x to the 4th minus 8x squared minus 9 equal to 0. All right. So what we notice here is that we have x squared. Oh, I still have my eraser on. We have x squared right here, and then x to the fourth is x squared squared. And so that's what I emphasized right here. We have x squared, and then we have x squared squared. So whenever you have that type of scenario, it fits your quadratic equation or quadratic form, where you have this term right here, and then this term, that same term squared as your leading term. So one way you can handle this type of problem is that you can, if you want to simplify it, you can let u, what you would do is pull just a random variable. Most times it's called you use u because of u substitution. You let u be equal to x squared. So that means we're going to plug in u where we see that x squared. And that's what we have right here. U squared minus 8, u minus 9. All right. Any questions on what we've done up to this point? Make sure we're good. So now we can factor. That'll be u minus 9 times u plus 1 equal to 0. Set each part equal to 0. And we have u equal to 9 and u equal to negative 1. So whenever you use the substitution, don't forget that you're not finished until you substitute what you originally had back into your equation. So our answers aren't 9, or are they, or is one of our solutions negative 1? But we're almost there. But we have to let u go back to being x squared. Because if you were to go back to your original equation, and we talked about this before, our highest exponent is 4. In other words, the degree of our equation is 4. So that means we should get 4 solutions. And at this point, we only have 2. So somewhere we should, it should trigger that we're missing something. And what we're missing is putting x squared back into the equation, which is what we originally started off with. So we have x squared equal to 9 and x squared equal to negative 1. All right, so now solve for x by taking the square root of both sides. Don't forget your square root property. Whenever you take the square root of both sides, plus or minus has to be involved. And so that'll be plus or minus 3, and then plus or minus I, which is square root of negative 1. All right, questions? All right, can I scroll up? All right, next one is a problem that's similar to that situation or similar to that setup. We have 5x to the 2/3 plus 11x to the 1/3 plus 2 equal to 0. This, once again, is a quadratic equation in quadratic form. So reason being is because we have x to the 1/3 that's beside that 11. but also x to the 1/3 or x to the 2/3 is x to the 1/3 squared. That's next to that 5. So whenever we have this type of situation, when we have x to the 1/3, and then in the next one, or the one previous, is that 1/3 x to the 1/3 squared, then we can rewrite our problem by letting u be equal x to the 1/3. And now we have a regular equation of 5u squared plus 11u plus 2 equal to 0. All right, questions before we go to the next step?
So you squared the x to 1/3 so you could get similarities.
Well, actually, we broke up. It's not necessarily, it's like almost like factoring where you reduce, or not reduce, but reverse the multiplication process. So all I did was look at 2/3 and recognize that 2/3 is 1/3 times 2 over 1. So it's just 1/3 times 2. And whenever you raise a power to another power, that's what's happening. You're multiplying your exponents. So basically, I reversed what happened. I recognized that 2/3 is 1/3 times 2. And that's what happened here. So we have 2/3 here, and then here I broke up the 2/3 into 1/3 times 2. Hopefully that helped as far as the explanation.
Yeah, I got it. Thank you.
Okay, cool. All right, and go up. Everybody good? All right, so once again, I'm in this position. So I look to see if I can factor. And then also, once again, if you're not comfortable with factoring, you can always use the quadratic formula that will get you to the same result. So I broke it up to 5u plus 1, u plus 2. And that brings me here. U equal to negative 1/5 and u equal to negative 2. Any questions? Any questions? Once again, just like our last problem, try not to get too happy because you come down to two values. Because if you use u substitution, then you need to back substitute the x to the 1/3 power in for u. So we have u to the negative 1/5. So that means that's going to be x to the 1/3 equal to the negative 1/5. And then we'll have x to the 1/3 equal to negative 2. All right, here in the purple circle, green lettering, just re-emphasizing what x to the 1/3 actually represents. That is the cube root of x. X to the 1/3 is the same thing as the cube root of x. So in order to get rid of the cube root of x, I need to cube both sides, raise both sides to the 3rd power. That's what I did in my next step. Cube both sides. So x to the 1/3 and cubing that will cancel out, just leaving you with x. Negative 1 over 5, cubing that turns that into negative 1 over 125. And then cubing both sides in that next equation will leave you with x equal to negative 8. Any questions? All right. I think this is we got one more type of problem in this section. I think this is it. Yeah. Yep. So we see 1.6 had a lot going on in it. Is everybody done with this before we look at the last type of problem? All right. So the next one is absolute value equations. And like I said, it's the last type of problem in this section. So we have the absolute value of 2x minus 3 equal to 11. So whenever we have, if you haven't seen absolute value in a while, or maybe haven't seen it at all, there's just these longer lines. Those are considered absolute value. Let me see, did I write it? Well, that's right here. It's good enough. Whenever you take the absolute value of a number, it's always going to end up the positive result. So if I take the absolute value of 11, the result will be 11. If I take the absolute value of a negative 11, the result once again will be 11. So the absolute value will always yield a positive result or the positive representation of that number. All right. So if I want to solve and I want to know when is this statement true, I want to know when is it positive 11 and when is it going to be negative 11, because once I apply the absolute value, my result will be positive 11 anyway. So the way we'll set it up is by what's here in the red. If I have the absolute value of a quantity equal to a number, I will write that quantity equal to that number and then write that quantity equal to the negative number. So let me erase this. So this is how we would set up our absolute value solving. So notice I have 2x minus 3 equal to 11, just how I saw it. And then 2x minus 3 equal to negative 11. That's how you always set up your net absolute value equations to go ahead and solve. All right, questions on the setup? All right, so from here, go ahead and solve your equations. Add 3 to both sides. You cancel on the left. And that leaves us with 2x equal to 14, 2x equal to negative 8. All right, and then we will go ahead and divide both sides by 2 in both cases. Results, x equal to 7 and x equal to negative 4. All right, questions on that before we look at another one? All right, next one. Oh, somebody said something in the chat. You don't necessarily have to check. If you do these correctly, you should have the right answers. That one that I mentioned checking, that one you have to check, because even if you do everything correctly, because you may have squared both sides or raised both sides to an even power, that manipulates the problem in such a way that it will probably produce a solution that's extraneous, or in other words, a solution that will not work. So that it's because of the nature of those radicals that you will have to check those, but these should work out in both cases. Now, is it good to check? Yes, it's always good to check, but these, if you do them correctly, your answers should be correct. All right, so here we have 5 times the absolute value of 1 minus 4x minus 15 equal to 0. So notice the first thing we want to do here, and yep, is isolate the absolute value. If you go back to our original setup, our absolute value was isolated on one side. So you had absolute value of u equal to c. So if we want to apply, did it go? Okay, there you go. Just want to make sure. So if you want to apply the method that we just finished looking at, you do want to isolate the absolute value. So we're going to add 15 to both sides. That would be this result, well, with the 5 in front, and then we'll divide both sides by 5. And we'll be left with the absolute value of 1 minus 4x equal to 3. Any questions? All right, so now, once you've done that, you set each side, well, I won't say it like that. You set 1 equal to 3. So you write it the way you see it, 1 minus 4x equal to 3. Then set 1 minus 4x equal to negative 3. So that will be the way you set it up. Then from there, go ahead and solve your linear equations. Subtract 1 from both sides in both cases. That will result in negative 4x equal to 2 and negative 4x equal to negative 4. Then you can go ahead and divide both sides by negative 4. And the results will be x equal to negative 1/2 and x equal to 1. All right, any problems before we look at, I think there's one more. All right, so here, this one, you just have to pay attention to what's going on. Can mess you up, trick you up a little bit if you're not careful. We have the absolute value of 3x minus 7 equal to negative 21. So the key to this one is when is this equation true? That's what we're supposed to be asking ourselves anyway. When is, this equation true? When is this going to work? In this case, when is the absolute value of 3x minus 7 equal to negative 21? And the answer to this is never. Because remember I mentioned before, the nature of absolute value is that once you apply the absolute value, your result is always positive. So that's what I have right here in the purple. The absolute value of a number is never negative. Once you apply the absolute value, you will always get a positive result. So this could never be true. The absolute value of 3x minus 7 equal to negative 21 is never true. So that means your answer is no solution. All right, so you just have to be careful. If you end up with a negative once you've isolated your absolute value, if you end up with a negative on the other side of your equation, then your answer is no solution. All right, questions. All right, so it's 12:20. Let me check it. 1.7 is standalone. Okay, so we'll pause right here. I think I hit you guys with a lot of stuff to chew on. From out of 1.6, 1.6 has a lot of content in it. So there are only 6 sections. Just because we started at 1.2, goes from 1.2 to 1.7 out of chapter 1. So we only have one more section out of chapter 1 as far as content is concerned. So remember I said when we got around 1516, we'll look at putting a due date out there for chapter 1's content. Remember chapter 1's test is also already posted, so it's something you can go ahead and knock out on your own. At least it should be posted. Let me know if you don't see it. So today is the 3rd. Because let's see, we'll do 1.7 next class. I'll give you till, I think the 20th is more than enough time. So I'll 6:20 is, I think, is a decent amount of time to go ahead and get chapter 1's content completed. And it will be reflected in my math lab at some point. That should be a Sunday, so June 20th. You should be looking to be done with chapter 1's content. Now, that doesn't mean that we're going to stop moving forward, of course. I'm just putting a date out there, so saying, hey, we most definitely need to be done with chapter 1 by this date, so that you can be, ready to move on in chapter 2 and knock out chapter 2's stuff. All right. Questions on that? Any
Did you
questions?
just say that we were gonna have a test review?
But a test review has already been posted in Math Lab. It should be as one of your homework assignments, if that's what you're asking.
All right. Yeah. Thank you.
Yeah. So now, if you have questions, every day is an opportunity for questions. So just like right now, it's 12:20. This would be a great time for anybody that had questions. You may not have them right now because you may not have gotten fully into the part where questions may have arrived. But next class, most definitely. You have this weekend to get into the stuff. Most definitely, next class after we talk about 1.7, if you have questions, then this would be the opportunity for you guys to ask them. Before you get into chapter 1, remember your test reviews are not mandatory, but if you get an 85 or better on them, I will give you extra credit, 5 extra points to your test. But it would be to your benefit to at least look at what's in the test reviews, because that will help you streamline your studies for the actual test itself. All right, I see some tests. Yep, yeah. Oh no, it's fine. But yep, everything from chapter 1 will be due 6:20. Yep. And then of course something happened. You know, that weekend you were about to knock out some stuff, then the goldfish jumped out the bowl. Just shoot me an email, and then we can work it out. But that's that's our due date. So if you have any type of issues that occur, it's best to make sure you keep all lines of communications open so we can work it out. All right. Anything else? Anybody else before we hit this weekend? Everybody good? All right. So you guys have a great one. Be safe. I will see you on Tuesday. Ready to close out chapter 1. You guys take care.
Thank you. Have a good weekend.
Thanks, you the same.
Thank you.
Thank
Have a
you.
good one.
You have a great weekend, sir.
Thank you. Thank you.
Professor.
Appreciate it. Thank you. Take care.